Welcome back, Math 30-1. In this lesson here, we're going to look at solving second-degree trigonometric equations. And now, this is kind of like doing quadratics and doing factoring quadratics with trigonometry. It's not that bad, and I'll show you how we do it. So let's start off here. If I have 8 tan A plus 4, that looks complicated, but if I said tan A, let's just say tan A is the same thing as x. We're going to let tan A equal to x. So in this case here, that's like saying 8x plus 4. Now to factor this out, we would just go back from way back in the day. We know we just could divide both of those by 4. So that's going to be the same thing as 4 2x plus 1. Now we said x is tan A. So I'm going to substitute x with tan A back again. So this is going to end up giving me the same thing as 4 2 tan A plus 1, all in brackets. Okay? So let's take a look at the second one here. Now, if I looked at this, I'm going to say these are equal to z. So I'm going to say sine x is equal to, or we'll put j. Okay? So basically here I have j squared minus 3j. Okay, so I want to know how to factor that. That's going to be the same thing as saying j multiplied by j subtract 3. Well, I said j, or I let sine x equal to j, so that means I'm going to put sine x back into for each of my j's. Alright? So I'm going to end up getting here then for my final solution, we're going to have sine x multiplied by sine x minus 3. Okay? Let's take a look at this one here. This is really, if I looked at this, I'm going to say sine x is equal to j, so 4, or sine x is equal to j. So here I have sine x squared, so that's really like saying j squared, so I'm going to put 4j squared minus 1. Now this looks very simple. This is just a difference of squares. So this is the same thing as 2j minus 1 multiplied by 2j plus 1. And remember, we said sine x is the same thing as j. We let sine x be j. So this is really equal to 2 sine x minus 1 multiplied by 2 sine x plus 1. All I did was plug in my j's and sine x's. So I'm going to do one more here for us. Let's take a look at this one here. Okay, so we want cosecant of x. So I'm going to say cosecant x, so let's put this here, cosecant x is equal to, we're going to let that equal to, I'm going to put a k. Okay? So looking at this here, we have k squared is equal to 3k minus 28. Oops. Minus 3k minus 28. So we just do our quick little box method here. So I have minus 28 and minus 3. So what two numbers go? That's 4 and 7. So I'm going to have negative 7 and positive 4. So that's the same thing as k minus 7 and k plus 4. Alright, now we said k was cosecant of x. So I'm going to have to put in cosecant of x back in for k. So we have cosecant of x minus 7, and then we're going to multiply it by cosecant of x plus 4, and that is my solution factor. Okay, so right here, just going to highlight my solutions for each one so we can see them. There's one solution, there's my other solution, there, and we have a solution there. So let's take a look at class example number 2. Basically, there's two ways of doing this. We could either make this equal to 0 and push everything onto this side of the equation, or I could just graph this side of the equation and then this side of the equation. I'm going to just do the first method of graphing, or the second method graphing this side of the equation and graphing this side of the equation to get all of our solutions. So I'm going to go y is equal to, and I graph both of those on both sides. Okay? And we know it's in radians, so I'm going to make sure my mode is in radians. Okay, good. And we want my window is between 0 and 2 pi. And my scale is pi over 2. My minimum is -3, max is 3. That seems about right. We're going to graph. And my graph looks something like that. So in order to find the solutions for this, we want between 0 and 2 pi, which is what we wanted. We want all the solutions, and then as an exact multiples of pi, all I'd have to do is we would go second calculate, and we want to find our intersections of our two graphs. So our first one is going to be, I'm just going to take one of them right here to show you how we get it, and you could get the rest. So my first one, we want the first curve is around there, second curve there, and my intersection is, we have 2.617939. Okay? So I look at that, so I have 2.617939, so I'm going to second quit, and I go, and I'm going to divide, go x divided by, and we're going to go second answer, or sorry, divided by second pi, which will give me 0.833, and I'm going to go math, fraction, enter. So I get 5 pi over 6. So one answer here is 5 pi over 6. So we know that's one of them. So basically why I took that value and then I divided it by pi is to put it in fraction form, and then we just multiplied pi in at the end. So we know that's one of the answers, and that is going to be, oops, window, graph. So, and that is this one here, and we have two other answers in there. And those two other answers will end up being, they are going to be pi over 6, and we also have 3 pi over 2. Okay? And then it says state the general solution to the equation. So my general solution to the equation is going to be where x is equal to pi over 6 plus 2 pi n. And then we're going to have 5 pi over 6 plus 2 pi n. And then we're going to have my last one, which is 3 pi over 2 plus 2 pi n. And we want where n is an element of integers. Okay? So that's how we generally do that one there. So let's take a look at the algebraic stuff where we really have to get going. So it says consider the following equation. So that's just the equation we had before. Use an algebraic approach to determine the roots between 0 and 2 pi. So now we're going to do the algebraic approach. So first thing I want to do is, this kind of looks like a quadratic, and I'm going to pretend it is. So I'm going to say let sine x equal to, I'm going to put an f here. Okay? So I'm going to have 2f is equal to 1 minus f. So I'm going to now, if I want to solve for f here, I'm going to move everything to this side of the equation. So I'm going to get 2f, and we're going to get plus f minus 1. Okay, so now I'm going to do a quick little box method to factor. Right there. I have negative 2, and I'm going to have 1. So that's going to be 2 and negative 1. So then, I look at that, that's 2 over 2, and negative 1 over 2. 2 over 2 is the same as 1. So I have 2f minus 1 for 1, and the other one is going to be f plus 1 for my solutions. Okay? And these are equal to 0. But now, we said sine of x is equal to f. So I'm going to have, right here, we have 2 sine x minus 1. And we have sine x plus 1 is equal to 0. Alright? Now, both of these could be equal to 0. So I know 2 sine x is equal to 0. 2 sine x minus 1 must equal to 0. And we also know that sine x plus 1 is equal to 0. Okay, so let's solve this side here first. So this means sine x is equal to 1 over 2. This one here is going to say sine x is equal to -1. So let's see when these solutions are and where they are, which quadrants they are in. So I'm going to quickly draw my graph, and we know 1 over 2 is going to be positive y's are here and here, and 1 over 2 is going to be my short y, long x, which is going to be 30 degrees. And so this is going to be 30 there, which is the same as pi over 6. Okay? And now we want sine -1, which is going to be -1 is my long, and it's negative, which is right there. So my answers here is x is equal to, we have pi over 6, and my other one here is going to be pi minus pi over 6, which is going to give me 5 pi over 6. And we have right here, it's 3 over 2 pi, so my other one is going to be 3 over 2 multiplied by pi, okay? Because that's the 270 degrees. So state the general solution. Well, I look at that. I'm going to have x is equal to, we're going to have pi over 6 plus 2 pi n, okay? Then we're going to have 5 pi over 6 plus 2 pi n. And then my last one is going to be 3 pi over 2 plus 2 pi n. And we're looking at n is a value, is an element of all integers. All right? Okay, so now let's take a look at classroom example number 4. We have two solutions here. It says, or two questions here, A and B, and we want to use an algebraic approach to determine the roots of the given domain. So within that domain. So here we're looking again, this must be in radians because we're in terms of pi. But this looks complicated, doesn't it? So all I'm going to do is make this the same thing as sine A, I'm going to say, is equal to j. We're going to let sine A equal to j. So now when I have 4j squared minus 1, and we're saying that's equal to 0, this doesn't look that complicated, does it? So in other words, we're going to factor this first, and I'm going to get 2j, because this is a difference of squares, minus 1 multiplied by 2j plus 1 is equal to 0. Okay? Now, let's continue this here. We know that sine A is actually j. So I'm going to put sine A back in for each j. So I'm going to get 2 sine A minus 1 multiplied by 2 sine A plus 1 is equal to 0. Now I have two sides here to look at. Because it's factored, I know that, let's erase that there, we know that this here, we could have 2 sine A minus 1 is equal to 0. And we know that we could have 2 sine A plus 1 is equal to 0. Alright? So if I solve this, we could have sine A is equal to 1 over 2, or sine A is equal to negative 1 over 2. Okay? Now let's take a look at that, at my grid. Well, I know that sine could be positive or minus, so that means sine could be there, 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 or there. Now let's take a look at my reference angle, which would be in here. 1 over 2 is the short sine, so that's going to have to be 30 degrees. So this is going to be 30 there. 30 degrees, which is the same thing as pi over 6. So we have, on this one here, we have A is equal to pi over 6 for my positive, and we have 5 pi over 6. Now we look at this one here, it's my negative, so that's going to be pi over 6 plus pi, so that's going to be A is equal to pi over 6 plus pi, which is 7 pi over 6. And then we have 2 pi minus pi over 6, which is going to give me 11 pi over 6. So these here are my 4 solutions for my answer. So I actually have 4 solutions for this equation here. Okay, now let's take a look at tan x. So we want here between tan x squared plus tan x is going to be between 0 and 2 pi. Now I look at this, this is actually, it looks like two different so when we take a look at B, we're looking at tan x squared plus x is equal to 0 between 0 and 2 pi. Now normally this is two periods, okay? Because the period of tan x is normally just pi. So once again, this looks complicated, so I'm just going to let j equal to tan x, okay? So every time I have tan x, I'm going to put in j. So we're going to have j squared plus j is equal to 0. All right? Now, this is the same thing as j. We can factor out a j. We get j plus 1 is equal to 0. Right? So now let's put back in tan x for j. So I'm going to get tan x multiplied by tan x plus 1 is equal to 0. So now we have two different style of solutions here that we could look at. We have two factors. So basically I have tan x is equal to 0, and I have tan x is equal to negative 1. All right? So when tan x is equal to 0, and if I take a look at this, that means x, my y over x must be the same thing as, my y must be 0 and my x must be 1. So I have two places here. I have pi and I have 2 pi. So I have pi and 2 pi for this one there. Okay? So now when we're looking at tan x is equal to negative 1, well that means my x and y value must be the same. So those are my 45 degrees, but it's negative 1. So where is tan negative? So all these 45 degrees, my tan is only going to be negative here and here. Okay? Because one x has to be negative and the other one must be positive. So one of my x's have to be negative or y negative and the other one positive. So I look at that there. If I go, oh, we want in pi, so that's the same thing as pi over 4. Right? Because pi over 2 is that, so that's pi over 4. So I have 180 minus pi over 4, or pi minus pi over 4. So that's going to give me 3 pi over 4 is one answer. Then I have 2 pi minus pi over 4, which is going to give me a total of 7 pi over 4. Okay? So right here, these are all of my answers. So we know that x is equal to pi, 2 pi, 3 pi over 4, and 7 pi over 4. So those are all of my answers for x. So for our last example, number 5, it wants us to determine the zeros of the function of the specified domain. So I'm going to skip ahead and just go and do B for this one here. Now, right here, we want the zeros, so that means we want 0 is equal to 2 cosine of theta squared plus 5 cos theta minus 3. Okay, now this looks complicated, so I'm just going to let j equal to cos theta. Okay, so this is really 0 is equal to 2j squared plus 5j minus 3. Now I'm going to do a little box method on the side here, and we're going to get negative 6 and 5. So I look at that there, I'm going to have 6 and negative 1. So that's going to be 6 over 2 and negative 1 over 2. So that's 3 over 1 and negative 1 over 2. So that's going to be, give me j plus 3. And my other one is going to be multiplied by 1 over 3. So that's going to be, that's 2 there. 2j minus 1. Okay, so we're going to substitute this back in here. And this is really cos. So I have cos theta plus 3. And then we're going to have 2 cos theta minus 1. And we know these are equal to 0. Okay? So basically now we're going to solve for cos theta on both of these. So I have cos theta is equal to negative 3, or we have cos theta is equal to 1 over 2. So 1 over 2, that's my small one. So that's going to be the same as sine 60, or pi over, we're in terms of pi, yeah, pi over 6. So we want here is between pi and negative pi. So that's going to be pi over 6 is my reference. So I want between pi and negative pi, and we have this as 1 over 2. So that's going to be cos there or there. So in reality here, this is going to be pi and negative pi. So in reality, we could have this one right here, which is negative pi over 6 is one of my answers I could have. Oops. Okay, so now I have cos theta is equal to 1/2 and cos theta is equal to negative 3. So if I'm looking at negative 1/2 or 1/2, we know cos is positive, so it's there or there. And 1/2 is when cos is short and y is long. So that's going to be my bigger of 30, 45, and 60, which is going to be 60 degrees, which is the same as pi over 3. So we have pi over 3, but in this case here, we can only have negative pi over 3 because we are in between negative pi, so we go from negative pi and we go all the way to pi. So yeah, we have both of these here. We have pi over 3, and we also have, because we go from here all the way to there, so we're also going to have negative pi over 3. So those are going to be my two solutions here. So I'm going to have theta is equal to pi over 3 and negative pi over 3. Okay? So now let's take a look at cos of 3. Okay, so now for cos of 3, there is no solution for this. There's no way we can make it equal to 3. So this one here, there is no solution. Okay, so when I look at this here, we want to find all of my solutions that fit between pi and negative pi. So I'm going to add every time we're going to be adding in there. So if I add pi to this, or 2 pi to this, that's going to be too big. If I add 2 pi to this, it's going to be too big. So therefore, my only zeros are between are going to be pi over 3 and negative pi over 3 will be my only zeros for this equation. Since if I added 2 pi to this, that gives me bigger than pi. If I added or took away 2 pi from this, that's smaller than negative pi, and same thing with that one there.